Good morning, my dear students. Welcome in SOM lecture. So now, today we're going to start our next problem. See, a brass bar having a cross-sectional area of 1000 square. So see, given data, it is very important, right? Given data. So we have area. How much Area means A. So we have area 1000 square is subjected to an axial force as shown in figure. So what they said? They said we have one bar. See, brass bar. So see, this is a what? Brass bar. We have a brass bar, and that bar having cross section area. So area of this bar from this end to this end, from left to right, uniform area having this bar. How much area? 1000 area. So this is what? Area. And this area from this end to this end remains same, uniform area habitus of that brass bar 1000 square. So how much area is there? 1000 square. Okay, and this brass bar subjected to axial forces. Okay, axial forces as shown in figure. So on this bar having various forces, see these four on this bar is remain one, bar is same, bar is only one. So but on this bar having different forces axially. So see, 10 kilonewton from left end, 40 kilonewton, for 60 kilonewton and 30 kilonewton, but the direction of that bar some quite different. Okay, so this, see, the 10 kilonewton bar moving towards right side, 40 kilonewton bar moving towards left side. So direction of that forces on that bar quite different. Okay, so this is figure habitus with different forces. This brass bar having habitus, that bar loaded by different forces, some kinds of varying forces. So see, so what they want, find total change in length. They want to calculate change in length, total change in length. So see how to solve this problem. Calculate change in length of this bar which is subjected to different forces. Okay, so give answer to this, and you know very well change in length means PL upon AE. You know very well. So P means force, L means length, A means area, and E means Young's modulus. Okay, so before start this problem, we need to draw one diagram again here. So see how to solve it. Okay, same diagram I have to draw it over here because we want to convert this unit. Okay, then these are the what? Length. How much? 1 meter, 3 meter, 2 meter. So see, my dear students, convert. Okay, so we have an area in mm over here. Okay, we have an area in mm over here, but we have a length in meter. Okay, so area in mm and length in meter, but we want that uniform unit, you know very well. So convert this meter into mm. So how much mm becomes of this meter? So 1 meter is nothing but 1000 so let's convert this unit. Okay, 1 meter converted into 1000 3 meter converted into 3000 2 meter, this 2 meter length converted into 2000 unit should be same, must be same. Okay, so after that, second step is to do what to do? Provide sections, one section, number 2 section, and number 3 section. So we have a 3 section over here. Just we have to provide name. Section number 1, section number 2, and section number 3. Okay, and then rest of the things remain same. Section number 1 from left side loaded by 10 kilonewton. Are you getting? Section number 2 from right side loaded by 40 kilonewton. Okay, then section number 2 from right side loaded by 60 kilonewton, and section number 3 from right side loaded by 30 kilonewton. Okay, so my dear students, just focus on this figure, how this figure loaded by forces. So see, we have made three section, one section, two section and three section. So we have to solve this problem in section wise. Okay, so section wise we have to calculate first of all change in length. So take section 1, take section 1. So one section is C. This is what section 1. That one section having a length 1000 mm. Are you getting my students? And this one section C, section number 1. Now section number 1 having a left side. This is what? Left side. And section number 1 having this what? Right side. Okay. Left side and right side. So see, just focus on the sides of the sections. So just we took section number 1. So section number 1 from left side. So just observe how many forces have with section number 1 from left side. Only one force. Okay, so see, this is what 10 kilonewton. So from left side on this section having 10 kilonewton. Are you getting my dear students? 10 kilonewton. But this 10 kilonewton pushing this section number 1 from left side. It means this section number 1 from left side goes compress. Goes compress. Are you getting? Section number 1 from left side goes compress. This 10 kilonewton force compressing, pushing this section number 1 from left side. Are you getting? So from left side we have a force 10 kilonewton, pushing force. Which force? Pushing force. Okay. Now from right side, see my dear students. So from right side, just observe how many forces is here with us in section number 1 from right side. So just observe from right side. So look at original figure. From right side of that section number 1, how many forces are there to making impact on this section number 1? So from right side, see, first force is there. From right side, first force is there. That is what? 40 kilonewton. See, how many kilonewton? 40 kilonewton, first force. And then first force, see what? First force again pushing this section number 1. This first force, see, again pushing this section number 1, compressing this section number 1. Compressing means minus. Compressing means minus. Okay, compressing means minus. Then section 1, see section number 1. Section number 1, right side over. Section number 1, see, left side is over. Section number 1, right side. At the right side of this section number 1, how many forces are there? Yes, first force, 40 force is pushing this section number 1 from right side. Pushing means minus. Then another forces are there from right side of that section number 1. Another force is C, 60 kilonewton. 60 kilonewton, see the direction of that arrow, 60 kilonewton force with direction. This force is responsible to pulling this spot section number 1. Section number 1 get pull, section number 1 get pull, section number 1 get elongate. This 60 kilonewton force, see direction of this force. This direction of the force is towards this side. Okay, so from this 60 kilonewton force pulling this section number 1, just focus on section number 1. So whatever the forces have it is at the right side of this section number 1, see how many forces? 40 kilonewton, 60 kilonewton and 30 kilonewton. So 40 kilonewton, this 40 kilonewton, what is doing over here? Yes, it is pushing. Pushing means negative because it is compressing this section number 1. Now 60 kilonewton, this force pulling this section 1, yes, it means it will elongate. This section number 1 goes elongate. This section number goes, length goes increase due to this 60 kilonewton force, because the 60 kilonewton force having a direction to away from the what? Section number 1. And pulling means plus 60. Pulling means plus 60 because direction of arrow showing, yes, I am going to pull that section number 1. Just focus on section number 1. Focus on section number 1. Now, last force which is available at the right side of this section number 1. So see, that is what 30 kilonewton. And what it doing? This 30 kilonewton, see direction of this 30 kilonewton, pushing direction. It means this 30 kilonewton pushing this section number 1. Pushing means compressing. Compressing means minus 30. So all forces get over, which is available at the right side of a section number 1. But from left side we have only one force. We have only one force, that is what? Compressive force. And compressive force means pushing force. Pushing force means always minus. Are you getting? So what we getting, my dear students, in section number 1? In section number 1, and the length of section number 1 is how much? 1000 mm. What we'll getting? Yes, from, see, this is only line, this is only line. Okay, so from left side we have only one force, that is a minus 10, and from right side we have a minus 40 plus 60 and minus 30 according to the direction with respect to compressing and pulling. You know very well, pushing and pulling. So see, 10. Okay, next figure, minus 10. So this is minus. Minus means pushing, compressing. Okay, so this minus, remove this minus and convert into arrow. So see, this is an arrow, pushing. This sign, we have a sign minus, but this minus sign converted into pushing. Yes. Okay, so it remained 10 kilonewton. So pushing force, it becomes pushing force. Minus means pushing force. It becomes 10 kilonewton. Direction is how much? Pushing. Okay. So next, minus 40 plus 60 minus 30. So 60 minus 30, 30. 30. 30 minus 40 minus 10. And minus 10, convert this sign into pushing form. So this 10, okay, replacing by arrow, convert this. Okay, so 10 kilonewton, and from this side also 10 kilonewton. So we got success to make complete section number 1. So this is what effect, pushing effect will produce. Okay, so see how to calculate this change in length, because this section number 1 get compressed. From right side 10 kilonewton, from left side 10 kilonewton. So how to calculate this change in length? See, change in length of a section number 1. You know change in length, PL upon AE. So change in length is equal to P. How much P? Yes, this is what force. This is what force, and this is what length, 1000 mm of a first section. So P is how much? 10 kilonewton. P is how much? 10 kilonewton. Kilo means kilo having value, K having value 10 raised to 3. So 10, K having value 10 raised to 3. And length of that same section, because we are calculating change in length 1. So section 1 having change in length, section 1 having a original length 1000 mm. So original length of a section 1, is what? 1000. Okay, area remains same. See, area remains same for all section. Uniform area is there. So area remains same. So area is how much? Again 1000. And what about Young's modulus? So we don't have Young's modulus. Okay, so just if you don't have Young's modulus, so assume in given data, assume Young's modulus is equal to 1 into 10 raised to 5 Newton per mm square. This is a assumption. If we don't have Young's modulus in this fashion, in this type of problem, so just we have to take this Young's modulus 1 into 10 raised to 5. Basically, this Young's modulus they have given into what? Statement. But right now we don't have, so let it assume. So assume Young's modulus 1 into 10 raised to 5 Newton per mm square. So Young's modulus have it as 1 into 10 raised to 5. So if you are going to solve it, calculate it. So we'll getting change in length. Change in length is 0.43 something mm. Okay, my dear students. So this is what change in length 1. Okay. Because change in length having unit what? Mm. So just you have to do multiplication over here. 10 into 10 raised to 3 into 1000 divided by 1000 into 1 into 10 raised to 5. So you're getting easily by calculator these calculations. Okay. So this is what change in length 1. So in this same fashion, we have another section number 2, section number 3. So what about section number 2? So see, section number 2. So section number 2, see, section number 2. So see, section number 2 having some length. How much length is there? Section number 2. Section number 2 having a length 3 meter. So see, 3 meter. 3 meter means 3000 mm. This is the length. Now see, again our problem comes over here. We want from left side and from right side how many forces are there. Okay, so see, first of all, section number 2 from left side. So how many forces have with us from left side of this section number 2? So see, how many forces have with us for the section number 2 from left side? Yes, 1 and 2. So these are the two forces have with us from left side, and two forces have with us from right side. Okay, so see, from left side, first force from left side of this two section, first force C from left side, first force how much? 10. And what is doing this 10 kilonewton force? What is doing this 10 kilonewton force to this section number 2? Just focus on section number 2. Section number 1 goes over. Okay, so section number 2, just focus on section number 2. Section number 2 and left side. So from left side of the section number 2 having a two forces. But first force, what is doing? This first force is doing pushing effect. Which effect? Pushing effect. See this 10 kilonewton arrow of this 10 kilonewton towards left side of this section number 2. So from left side of the section number 2 goes push. Push means minus. Okay, so first force minus 10. First force minus 10. Now second force from left side 40 kilonewton. And effect of this 40 kilonewton on this section number 2, yes, it will always moving away. Away means this 40 kilonewton responsible to elongate this section number 2 from left side. So this 40 kilonewton elongating the what? Section number 2 from left side. Okay, so elongation means plus, because length goes increase due to this. So plus 40. Okay, so see, plus. Okay, so is there another force? No, only two forces is here from left side. So 10 pushing means minus, and 40 pulling to this section from right side means plus. So 10 minus and plus 40. So plus 40 and minus 10. Okay, it will become 40 minus 10, it will become 30 kilonewton. Okay, so now section number 2, we are in section number 2. Okay, so at the right side of section number 2, again we have two forces. Now first force from right side, see, this supposed to be assume this one 30 kilonewton force always pushing this what? Pushing this what? Section number 2 from right side. Pushing means minus 30. Okay, pushing means minus 30. Now next force have with that is what? 60 force. What are you doing over here? This 60 force to this section number 2 from right side, pulling. See arrow, pulling means elongate means plus 60. So how it comes? 60 minus 30, it comes 30 kilonewton. Here also come 30, here also come 30. So our next figure it was plus 30 means tensile. Okay, here plus 30 means tensile, plus means elongate. So 30 kilonewton. This is what? Plus 30 means elongate, and minus means pushing. Okay, and length is how much? 3000 okay mm. So now we are ready to calculate change in length of section number 2. So we know formula change in length PL upon AE. So P, how much P? 30 kilo, K having value 3 into L of this section number 2, length of the section number 2, 3000. Okay, area remain same 1000, and next modulus, you know how much? 1 into 10 raised to 5. So after solving, you will be getting answer. Okay, 0.58 something mm. Calculate these things. Okay, now next force change in length 3 means section 3. So section 3, focus on section 3, my dear students. Section number 3, see section number 3 having a what? 2000 length. See, this is the section number 3. Section number 3 having a length 2000. So see from left and right side how many forces are there. So see, just focus on section number 3. See from left side and right side. So from left side of the section number 3 having a 3 forces. See, first force exactly on this one, it will what? Pushing this section number 3 from left side. See, my dear students, from left side of this section number 3, where in section number 3, just focus on section number 3. So at the left side of this section number 3, we have how many forces? 3 forces, first, second and third. See, this is the third section, and from at the left side of this third section we have 3 forces exactly on this one, then second and then third. So these are the 3 forces which is available at the left side of this section number 3. So see, first force at the left side of this section number 3, that is what? 60. And 60, what is doing this 60 over here, this at this side of this section number 3? Yes, pushing means, see, arrow doing matter, arrow pushing this section number 3 from right side. So pushing force is there. Arrow means direction showing, yes, pushing means negative, minus 60. So minus 60 from left side. Okay, then another force is here, 40 away. It's showing direction away from this section number 3. Away means this part from left side, this third number part, section number 3, with this 40 kilonewton. See direction of arrow of this 40 kilonewton, it will moving away from this section number 3. It means elongation means positive. So plus 40. Then next force have with us what? 10 kilonewton. What is doing this 10 kilonewton? See direction of arrow, yes, it will pushing this section number 3. See direction of arrow from left side. So pushing means minus 10. So what is value? Minus 10, minus 60, and minus 10, minus 70 plus 40. Minus 70 plus 40, okay, 30 kilonewton. But minus 30 kilonewton answer is there. Okay, minus 30 kilonewton. Okay, so see from right side what is there. So from right side, see right side section number 3, focus on section number 3. From right side we have only 30, but the 30, see direction, pushing. At the right side of this section number 3 we have 30, but direction of arrow, it will pushing this what? Section number 3 from right side. Pushing means minus 30. So minus 30. So see, just modify it. Section number 3 we have 2000 mm length. So see from left side and right side how force is there. So see minus 30, see minus 30, this minus 30 means pushing force is coming over here, and this is what? 30 kilonewton. See this minus sign just converted into pushing. Okay, so 30 kilonewton. Okay, so force becomes 30 kilonewton at this section number 3. So at this section number 3, change in length 3, PL upon AE. So P is how much? 30, K having value 30 10 to 3. Length of this section number 3, 2000. Area remains same. Area have with us what? 1000. And Young's modulus remains same. We have assumed it 1 into 10 to 5. And if you are solving this problem, so calculations, you're getting something 0.68. So just calculate it. Okay, so we got answer. Yes, we got it. Change in length, total change in length, 1 plus change in length 2 plus change in length 3. So change in length 1. How much change in length 1? 0.43. How much change in length 2? 0.58. How much change in length 3? 0.68. So it will gives us answer. Okay, so calculate it. You will getting change in length. Okay, so in this fashion we have chance to solve this problem. Okay, so calculate total change in length. So see, my dear students, in this way we have completed our chapter number 1. So in next lecture we'll have to switch on chapter number 2. Thank you very much.